Welcome to The Explainer. Today, we are unpacking the actual blueprint for humanity's return to the moon. And I don't mean just to visit, I mean to stay. So the biggest question really isn't if we'll go back, but how on earth do we even get started? Well, before we can even dream of building anything, we have to face this massive, massive hurdle. This number right here, $20,000. That's roughly the cost to launch 1 single kilogram of anything from Earth and land it safely on the moon. A bag of sugar, a small laptop, you name it, it comes with that astronomical price tag. That one number, it changes everything. It forces us to throw out the old playbook. You see, the old model of just shipping everything you need from home is completely, totally unsustainable. To have any chance of succeeding, we have to find a radically new way to start. All right, so here's our game plan for this explainer. We're going to kick things off by really digging into that cost problem. Then we'll look at the new blueprint, the smarter approach. We'll explore this wild idea of living off the land, check out the robots that'll do the building, and finally get into the new human challenges we're going to face out there. Okay, first things first, let's really wrap our heads around this barrier, because it isn't just a line item on a budget. No, it's more like a fundamental law of physics and economics that shapes every single decision that comes after it. It's pretty simple, right? When every single bolt, every prepackaged meal, every drop of water costs a fortune to get there, real colonization is just a fantasy. Sure, you could manage a temporary science outpost, but a real, self-sufficient settlement? Impossible. Not until we break our total dependence on that long, expensive supply chain from Earth. So if that's the problem, what's the solution? How do we crack this nut? Well, it's not about one giant, ridiculously expensive leap. It's way smarter than that. It's about a series of deliberate, cost-effective baby steps. The answer is this concept called lunar COTS. And think of it this way. Instead of NASA having to invent and build everything itself, it basically creates a market. It partners up with private companies. Now, this model, it stands for Commercial Orbital Transportation Services, has already been a huge success for resupplying the space station. It just sparks competition, drives innovation, and most importantly, it brings the costs way, way down. And hey, this isn't just some theory on a slide. It's actually happening right now with NASA's Artemis program. This is the roadmap, and it's designed from the ground up to weave together both government missions and commercial partners. The goal isn't just to put boots back on the moon, it's to use that mission as the foundation for a permanent human presence. Now, what's really brilliant here is how this whole colossal task gets broken down into manageable chunks. Step 1, send in the robots. Let them do all the hard, dangerous groundwork, setting up power grids, communication arrays, all the basic utilities. It's only after that foundation is set, and after we've tested our new tech on a small scale, that we start scaling up to support a permanent human outpost. Let's move on to the absolute game changer, the one thing that makes all of this actually possible. This is the core idea that takes a lunar base from science fiction and turns it into a real engineering problem we can solve, using what's already there. Okay, the fancy term for it is in situ resource utilization, or ISRU for short. But all it really means is living off the land. It's a super simple concept, but it's everything. Instead of launching it all from Earth, we find it, we mine it, and we use it on the moon. This is the key that unlocks a sustainable, self-sufficient settlement. And you might be surprised, but the moon is basically a hardware store in the sky. In these super cold, permanently shadowed craters at the poles, you've got tons of water ice. That's water to drink, oxygen to breathe, and rocket fuel. The lunar soil itself, the regolith, is over 40% oxygen by weight, just locked up in the minerals. Plus, it's packed with useful metals like aluminum and titanium for building things, and silicon for making solar panels. And this is basically the blueprint for the very first lunar factory. You've got a whole supply chain here. It starts with little robotic prospectors that go out and sniff for the best deposits of water ice. Then extraction machines come in, heat up the soil, and capture the water vapor. That water gets purified or it gets zapped with electricity to split it into oxygen and hydrogen. And finally, you use those finished products for everything: life support, building materials, and even fueling the rockets that are going to take us to Mars. So we've got a plan. We've located our raw materials. Now, how do we actually, build stuff? How do we build the habitats and life support systems that are going to keep people alive? This right here shows you the huge mental shift we've had to make. On the left, you've got the old way, building a big, heavy habitat on Earth and somehow launching it to the moon.
On the right, you have the new, much smarter way. Launch something much lighter, like a team of autonomous robots, that will build the habitat for us, using the local lunar dirt. That one change, right there, could slash our dependence on Earth by over 90%.
So who's doing the building? Not people, at least not at first. We're sending in a robotic construction crew. You'll have fleets of specialized robots, excavators, haulers, and giant 3D printers that build structures layer by layer. They'll use these cool techniques like microwave sintering, which is kind of like a giant microwave that melts the soil into super strong bricks, to build landing pads, roads, and habitats. Some of the coolest plans even involve building inside ancient underground lava tubes for natural protection from all that nasty radiation. Okay, so we've 3D printed our house on the moon. Awesome. Now, how do we stay alive inside it? The answer is you have to build a tiny, self-contained version of Earth's ecosystem. It's called a bioregenerative life support system, and the whole goal is to create a perfect, closed loop where nothing, absolutely nothing, is wasted. So what does that actually look like? Well, you're talking about integrated greenhouses to grow food and generate fresh oxygen. You're talking about systems that capture every single drop of water, from showers, from the moisture in your breath, and purify it so you can drink it again. And yes, you're talking about composting human waste to enrich the lunar soil so you can grow more crops. The goal is to turn a sterile, artificial base into a living, breathing ecosystem. But all the engineering, all the biology, that might just be the easy part. The truly hard part, the part we're just beginning to understand, is the human part. This quote just says it all, doesn't it? The first lunar settlers will be living in the ultimate isolated, confined, and extreme environment, or ICE for short. Think about it. More isolated than any researcher in Antarctica, more confined than any sailor on a submarine. It's a whole new level of extreme. And the challenges are just immense, way beyond the technical stuff. You've got the constant threat of cosmic radiation because there's no real atmosphere to protect you. You've got the unknown long-term health effects of living in 1/6 gravity. And then there's the lunar dust. It's fine, it's sharp like tiny shards of glass, and it gets into everything. But honestly, the biggest challenges might be psychological, the crushing isolation, and this huge question of governance. How will this brand new society organize itself so far from everything we've ever known? So it seems like we have the blueprint. We know how to start, we have the technology, we know where the resources are, and we have a plan to build a home on another world. But as we stand right here on the verge of becoming a multi-planetary species, the ultimate question really isn't how we'll build, but who will we become when we do?